So I'm going to start with my presentation. For those who don't know me, my name is Alejandro Mura Belenda, and I am from Spain. Okay? I have 4 supervisors, 2 of them in engineering, which is Farid and George, and other 2 in lab, which is where I do my experiments. Okay? Ben and Kurt in lab. Also, no, thank you. Okay. I am very grateful because there are 2 postdocs that has been working in this project for the last 3 years, so they also give me advice and guidance. Okay? By the way, my PhD is about the production of a fertilizer from industrial waste, okay, which are the digestates and the ashes. So this is the index of the presentation. First of all, as a way of introduction, I'm going to tell you about the background of the project from a broad perspective and later in more detail. I'm going to tell you the approach that I've been following. I propose some aim and objectives. These are not the same for my PhD, but are okay for you to understand what I'm doing. And I include in the presentation some experimental design and preliminary results. Okay, so what is the current situation? In the current state is that we have a large demand of energy, large demand of raw materials, and we are producing a huge amount of waste. Okay? So in this situation, it makes sense the implementation of a waste management system. Particularly, in our case, we are interested in the recycling and reprocessing technologies. We are looking at the anaerobic digestion and the thermal treatment of the waste. What is anaerobic digestion? It's a fermentation that takes place in anaerobic conditions. So this microorganism produces the biogas, which is an energy source. Equally, the thermal treatment of the waste also produces energy. And both technologies has in common that they give an stable product, or at least more stable than the initial feedstock. So we have these 2 products, the digestate, which is the stable product from the anaerobic digestion, and the ashes from the thermal treatment of the waste. Okay? And in order to find a suitable application for both products, we assess the potentials and the limitations of the products. So, the potentials, both products has good characteristics to be used as soil amendment. Okay? The high content of the digestate, good organic amendment. And also has macronutrients, which are essential for plant growth. These are supplemented by the macronutrients of the ash. Ash has high content in phosphorus. The digestate has high content in nitrogen. So, if we blend it, ideally we have a fertilizer that is competitive with the commercial ones. Okay? This is the first limitation that we have. The fertilizing performance. Digestate can be used alone, but directly or after simple processing. But his performance is much worse than the commercial fertilizer, the so-called NPK fertilizer, nitrogen, phosphorus, and potassium. Okay? These are essential macronutrients. There are others such as sulfur. So, it is necessary some processing to improve the performance. Also, the second limitation, whether they are regarded as waste or not. If they are regarded as waste, you cannot use for production of food. Plus, if one is waste, the other not, the blend is waste. So, this is the most important regulation that we have to bear in mind, this European directive, okay, for the classification, whether they are waste or not. Processing, digestate, simple processing, the most common way of processing the digestate, 90% moisture, the watering, solid liquid separation, okay? The application of the whole digestate and the liquid fraction is the same. Why it makes sense the drying up? Because the transportation of water is costly. Okay? Advanced processing. As I say, the digestate is not competitive with the commercial fertilizer. They create granular fertilizer from digestate, improve the performance. Also, for the ash, important advanced processing to achieve the end of waste status. Okay? If we do the processing of both materials together, it is possible to find synergies. So this can be also one of the novelties of this PhD. If we find some synergy, these authors report that when they are processed together, the waterability of the digestate is enhanced because it's a problem. They use membranes for the solid liquid separation and it gives a lot of problems. So here, the aim of the PhD, develop a process for the production of the blender fertilizer. Simple. And for you to understand 3 steps, understand of the basic chemistry under simple condition, which means we blend both materials under simple conditions, simple blending, and we monitor how it changes the composition. So we can identify some conditions that we can propose at complex treatment. And finally, optimization of every step and the whole process. Okay, so this is pretty much the last slide. So here, experimental design at the top and some preliminary results at the bottom. For the understanding of the basic chemistry of the blend under simple condition, we have many parameters that we can play with, okay? We fix some of them. We fix the type of flask, the position, and whether it's open or not. We choose open because this enhances the change of the composition. Gas transfer will enhance the kinetics of the reactions. Also, we took 20 degrees C for the incubation room. And the parameters that we are playing with are the composition of the blend, the mixing, whether there is mixing or not, and the level of the incubation. About the preliminary results, we got that the total nitrogen in the water-soluble extract decreased when increasing the incubation time, which makes sense. What is the water-soluble extract? Basically, we do the blending, we have 1 gram of blend, we add 10 milliliters of milky water, we filtrate, and this is water-soluble extract, which represent the nutrients that are more easily available to plant. If you use other extractants, such as KCl, you get more nutrients, but these represent other conditions, okay? So, why is the decrease of nitrogen in the water-soluble extract? Because of the volatilization of ammonia. The ash has high pH. The digestate has neutral pH. pH of ash is 13. pH of digestate is 8. When you add this, when you do the blending, you shift the equilibrium of the reaction towards ammonia, and it volatilizes. So after the volatilization of ammonia, less nitrogen remains in the blend, which means less nitrogen reaches the soil. Conclusion. We need to do further assessment of that, of course, but this is an example how it works. Conclusion. We use an acid during the blending. Which acid? Nitric acid is good, is used for the production of fertilizer. So we use this acid, we decrease the pH, there is less volatilization of ammonia, and more ammonia reaches the soil. More nitrogen remains in the soil. I put some reference, but that is all.
Thank you very much. Okay, there is time for an extremely quick question for Alejandro, please.
Alejandro, which industry are you looking at for these applications? Which type of industry?
Agro-industry, agri-food. Yes.
Okay. Did you look in the water industry, how they deal with the waste and using fertilizer as the waste?
The water industry?
Yes.
You know, the processing of the digestate, when I was looking at the processing of the digestate, I was looking at the processing that they are using for sewage sludge. You understand? What do you mean? How they use the residues of the water industry for waste?
Yeah, I work in the water industry, okay, and they use the waste to dry out, as you mentioned, and they transport into the fields and use it as a fertilizer. So my question is, did you look at that topic?
Yeah, as I say, as a way of processing as far as I know, you know, primary, I am a bit out of the, even when it's my background, the primary settling, secondary wastewater treatment is the sewage sludge. These are the main products, dried products that they are using. You know, how they are dealing with the sewage sludge is that it's an oxidation. And later, later they dry up this product and they use it as fertilizer. Yeah. So I was looking.
Okay. Sorry. Thank you very much. We have in 20 minutes. We have a general question and answer session, and so there can be much longer discussion. But now in the interest of keeping time, so we have to moving on.
Okay.
Thank you very much. Thank you.
Thank you.
Sara?